previous videos, we looked at stoichiometry problems where we were given the mass of the reactants. In this case, we're dealing with solutions, and so we're not going to determine the amounts of reactants by mass, but instead we know the volumes and the concentrations of the reactants. And so we can use the molarity equation to get these volumes and concentrations into moles, just as in the previous examples we used the molar mass to get the masses in grams converted into moles. But once I have the moles, I will work these problems exactly like I would the other stoichiometry problems. So in this example, we're given the volume and concentration of potassium chloride, and we're given the volume and concentration of barium nitrate. This is a precipitation reaction, and the reaction is given here. And so we're told that the barium chloride is collected. We're told what the final mass of the collected barium chloride is. So we want to determine the limiting reagent, the theoretical yield, and the percent yield. And so we'll do these just like the previous stoichiometry examples. I'll go and find the moles of each reagent and then figure out how much barium chloride I could make from each one of the reactants. And whichever reactant gives me the smallest amount of barium chloride, I know that's the reactant that's going to run out first. That will be the limiting reactant. The mass of barium chloride that I can make is the theoretical yield. And then I'll use the actual yield along with the theoretical yield that I calculated to get the percent yield. So the first thing I need to do is find out how many moles of potassium chloride and how many moles of barium nitride I have. So to do that, we need to use the molarity equation, which is that the concentration is equal to the moles of solute divided by the volume of the solution. So to get moles, I'll need to rearrange my equation a little bit. And to solve for moles, I'll need to multiply both sides by volume. So my equation becomes the moles is equal to the concentration times the volume. So for the potassium chloride, the number of moles is equal to the concentration, and 25 milliliters is 0.025 liters. So I end up with the moles of KCl is 0.0300 moles. I'll do the same thing for the barium nitrate. And the moles for this one and 15 milliliters is 0.015 liters. And so my moles of barium nitrate comes out to be 0.0135 moles. All right. And then the last thing that I need in order to figure out the mass of barium chloride that I can make, I'm going to need to convert the moles of barium chloride into the mass of barium chloride. So I'm going to need that molar mass. So the molar mass of barium chloride, I have 1 barium and 2 chlorines. And so the molar mass that I get is 208.23 grams per mole. Okay, so I have the moles of each reagent from the previous slide. So now I'll see if each one of these is limiting reagent, how much product could I theoretically make? And so if I do KCl first, and I see from my reaction that the mole-to-mole conversion is 2 moles of KCl can make 1 mole of barium chloride. So I have 2 moles KCl, 1 mole of barium chloride. Then I'll hit this with the molar mass. From the previous slide, we know that 1 mole of barium chloride has a molar mass of 208 0.23 grams. And so when I multiply all that out from the KCl, the most barium chloride that I can make is 3.12 grams. All right, now I'll do the same thing for the barium nitrate. I'll see how much barium chloride could I make from it. Now from the chemical equation, this is a 1-to-1 mole ratio. So 1 mole of barium nitrate can make 1 mole of barium chloride. I'll hit this with the molar mass again. And so if I was able to convert all of the barium nitrate into products, I would make 2.81 grams. All right, so I can see that the barium nitrate, I only have enough to make 2.81 grams. So that means that the barium nitrate is my limiting reagent, and the theoretical yield is 2.81 grams. So that means the limiting reagent is the barium nitrate. So we want to know what the percent yield is. So remember that the percent yield is equal to the actual yield divided by the theoretical yield times 100. So our actual yield is 2.45 grams. So then we can get that the percent yield is 2.45 grams divided by the theoretical yield from the previous slide is 2.81 grams times 100. And so the percent yield that I get is 87.2%.